also,
Okay,
Yeah,
the first part wasn't, but this next part, I
oh,
think
okay.
the speaker will be recorded. Yeah.
Okay, so my name is Paula Lowe. This is Patterson Lake Association annual meeting on November 7th, 2022. The Lacey Fire District 3 Fire Station. I also wanted to mention that in the newsletter that I send, we talked about various committees and projects. We're only going to do what you're interested in, because if you're interested, you'll help. And one of the things we talked about at the picnic this summer was getting rid of those derelict docks. I don't know about you, but they drive me crazy when they're floating down the lake and the styrofoam breaks off, and it's really bad for the environment. So we talked to a couple of people who are interested in working on that and pulling them out of the lake. And one new guy who lives on the lake, Scott DeWitt, said he would get the heavy equipment to help pull them out. And Tom Holkiner said he would help with that, or Tom. Okay, sorry, wrong name, close enough, got your first name right. So that would be a fun project to do probably in the spring, and we'll need to get some dumpsters and stuff. That'll be a large, heavy project. Jane?
So, I mean, if other people are interested in volunteering for that or anything else, even if it's not a list, there are volunteer sign up sheets and other.
Yeah, so please pick up the sign up sheets at the front, and if you want me to email one to you, I can do that. Or if you have other ideas of things that you want to do, let us know. So we'll probably have our picnic again this summer. That was really popular, and oh my gosh, you guys are such great cooks. The food was amazing. I don't usually like potlucks, but wow, that was really, really good. I think everybody's been cooped up for so long, they're just glad to get back together again and really outdid themselves. So the other thing we want to ask for tonight is donations. So we've got a bucket in the back, or Mike can pass it around. If you have any donations, we'll take anything. If you need a receipt and you're giving cash, put your name on it so Celia can send you a receipt, or send us a check. You can mail a check, or you can put a check in there.
I might want to say that although we're a nonprofit, we're not a charitable nonprofit, so you can't deduct donations if there's contributions to our association.
Okay, so thank you for that explanation. So we do, as Mark said, we don't take dues, but we do take donations to keep the organization running.
And we make checks out too.
Pardon?
Patterson Lake Association.
Thank you.
Yeah. Okay, so our speaker's going to be on in a couple of minutes. He is from, his name is Rob Zazat. He's the principal scientist at Herrera Inc. in Seattle. There's a Herrera Inc. office in Olympia as well. He's past president of the Washington State Lake Protection Association 2 times. I know him from the Washington State Lake Protection Association. It's also called WALPA. Paula Cracknell, who worked for the county, is no longer working for the county. She's on the board for WALPA. And let's see. So he is going to talk about the common pollution sources in Patterson Lake, or in other lakes as well. He works in Seattle, but he works on lakes all over the state, and just talk about the typical treatment. So one of the things we're doing when we're looking at our lake, when we first do the lake studies, is we're looking at all the pollution sources. Where's it coming from? It's usually groundwater, stormwater drains feeding into the lake. It could be failing septic systems. It's a wide variety of things. And so we need to know what's coming into the lake and how to stop it. And there are a variety of ways to stop it depending on what it is. And most of those ways, for example, to take the stormwater, you have to go to the county to make changes in that direction. So what we'll do is we'll have a speaker for about 20 minutes, and then he'll have 10 minutes for questions and answers. I'd like you to keep your questions directed toward what he was talking about tonight, so we just stay focused on that. You want to see if he's coming online yet? It's almost 8. You're going to project him on the big screen, right? Or the PowerPoint? Yeah, he's got a PowerPoint presentation. He has a lot of experience in lakes. And like I said, he's worked on a wide variety of lakes through the years. Herrera Inc. is one of the companies that does integrated aquatic vegetation management plans. There are only about 3 companies left in the state that do that. And when we get to that point, when the LMD gets to that point, the county scientist sends out a request for proposals to all the companies that do that, and then they send in their, documents, and then the county scientist decides on which company is going to do that.
He's not here yet. Do you want to take a quick stand-up break while we're waiting?
Oh, yeah,
for him?
if you want to stand up and stretch for a minute, we got 1 minute until we get them online. The bathrooms are next. I don't know. Probably that, if there's a bathroom, I'm sure there's one in the lobby. Oh, yeah, in the lobby. Okay.
Okay.
So you're gonna put the PowerPoint up on the screen.
Yes.
Okay. Do you want to turn off the recording for a minute? Or you can add it.
Well, I don't know.
Algal biomass increases up the y-axis, and we find ourselves quite often in this hysteresis period where we're in a delicate balance between too many aquatic plants and too much algae, or too much algae and too few plants. And it's important to recognize that there is a delicate balance. I think those two pictures show the opposite extremes, but we're often in somewhere in the middle, and that we have these alternative stable states, and it's very easy to switch from one to the other. For example, we have to be cognizant of the fact that if we completely control algae growth, the aquatic plants will take off. They'll have much more light to achieve much more biomass. And conversely, if there's a lot of nutrients that's been stored in the sediment, but not a lot of algae growth, maybe just some benthic algae growth, but not phytoplankton growth, then the plants can take off, and so on and so forth. But moderate amounts, of course, are optimal for both ecological balance and diversity and fish productivity. So, trophic state, we have 3 trophic states: oligotrophic, mesotrophic, eutrophic. You probably know all about all this. We define it through 3 indices: phosphorus, because phosphorus controls chlorophyll, which is a measure of biomass, and Secchi depth, which is the transparency or water clarity that is primarily controlled by the amount of algae. So chlorophyll is our most important index because it's the measure of algae. And I have here your trophic state indices since 1996 through 2020 anyways, all I could find published. And I noticed how chlorophyll has been eutrophic above this line of 50 every year, except one in the eutrophic state, and so has phosphorus. Although phosphorus has fallen below it a few occasions, particularly in recent years. And looking at this, this increasing phosphorus in the gray line is very concerning, but it also did not result in an increase in algae. So you have more phosphorus in your lake in the last, well, in those recent years from 2016 through 2020, but not corresponding amount of algae. But toxic algae are a different thing altogether. Of course, they're all toxic algae are cyanobacteria. They're blue-green algae, and we're very fortunate in our state to have a toxic algae program where we can get free testing, learn and learn about toxic blooms, what they are, what the health risks are, example photographs. But it is 4 toxins that we measure. There are more produced, of course, by these algae, and we're learning more every year, it seems. The 2 most prominent ones are microcystin and anatoxin A. Microcystin is a liver toxin, anatoxin A is a nerve toxin. You have both of them in your lake. And this table on the bottom right is a summary of, about 11 years of data that I compiled from King County lakes, showing the preponderance of microcystin being exceeded in the samples, it's actually most tested for, is also mostly exceeded in both this number of samples as well as the number of lakes. 31 of 84 lakes in King County have toxic blooms due to microcystin, but only 4 of 77 lakes tested in King County have antitoxins. That's pretty consistent throughout Western Washington, at least anyway, that it's microcystin is typically a bigger problem. It's produced by the genus Microcystis, which happens to be a very high producer, as well as Anabina, which is now called Delicospermum. There are some others, but those are the 2 dominant producers of actually both toxins. Antitoxin A is produced primarily by Anabina, not Microcystis. And yeah, but the thing is that you can have different species. Other blue-green species don't ever produce toxins, and some species that produce them some days and not other days. And that's the part that we don't really fully understand. We're still working on. So here's a graph of their history of toxic algae that I downloaded from Ecology's website. On the top graph is microcystin, showing data since 2010, where in most years, 8 out of 13 years, you had a toxic occurrence in your lake. So it's not a new phenomena, and it's probably been happening long before they started testing. Actually, in 2007, the testing started, so I'm not quite sure whether a sample was submitted. No, that means no samples were submitted, but that doesn't say whether there was a bloom or not in those years. But interestingly enough, you also have an antitoxin. Usually one lake has one or the other, but I'm seeing more and more increasingly where we have both toxins being produced in a lake, and yours happens to be one of them, although not nearly as frequently is antitoxin a problem. Okay, so it's all about the phosphorus. Phosphorus is controlling the algae, so we need to understand where the phosphorus is getting into the algae. And these are just a diagram of all the different sources that we try to monitor and measure and estimate where cyanobacteria get in their phosphorus, of course, coming in from runoff and groundwater. And then there's the flux within the lake, which is an important aspect to understand. And it depends on your morphology, how deep your lake is. If you have a thermocline, how long the thermocline's set up, what is your area, hypolimnia or bottom water, where most of the sediment release. But I'd like to also note that sediment release can occur in those shallow sediments that are oxygenated. When we have very enriched sediments in our lakes, our urban lakes, there is a release of phosphorus from iron in even the shallow sediments, because so much microbial activity happens in the summer, warm months, that it can reduce oxygen in the sediments itself, even though it's present in the water above it, and phosphorus will still migrate out of the sediments in those shallow sediments. And an other interesting phenomenon that a lot of people don't realize is the cyanobacteria migration. Is actually, they're the only algae that can control their buoyancy. They will intentionally sit on the bottom of the lake. Actually, their spores will rest there all winter long, and they'll soak up a glorious amount of phosphorus and what do they call that, luxury uptake, and then have that phosphorus all stored in their cells and grow, and then they float up with their gas vacuoles and are able to reproduce in the upper waters. So this is just an example of a urban lake hypothesis that we just developed for Echo Lake, actually, and I'm working on 4 cyanobacteria management plans at the moment. We just produced a quality assurance project plan for this one, and basically this lake gets phosphorus from stormwater is quite apparent prior to even us doing the phosphorus budget. But the point is that the stormwater phosphorus comes in, the watershed phosphorus is primarily coming from the stormwater, and is coming in during the winter rain, such as we have now. And then those clouds turn off, the rain turns off in the summer. And then the algae are growing in the summer, they're actually are growing from watershed phosphorus, but it's coming up from the sediment. So the phosphorus comes in from the sediment, sits down there, and then the microbes reduce the oxygen in the warm water in the summer, and then that released phosphorus from that activity, and the iron fuels those algae blooms during the summer. So indirectly, that's where you're fueling algae from the watershed sources during the summer. Anyway, to figure it all out, we like to do a water and phosphorus budget, which I'll get into, and then we use that amount to determine how much phosphorus do we need to reduce the corresponding amount of chlorophyll to ultimately get to a level, usually maybe the eutrophic threshold we target, that we know that with that reduced amount of chlorophyll, it's unlikely that blue-green algae will be a predictor. We don't typically create very complex ecological models that predict different types of algae growth. Those are challenging, and we don't use them very often, although I am doing one now for the Vancouver Lake. And then ultimately, we evaluate both watershed management alternatives and in-lake alternatives for reducing the amount of phosphorus, and that will in turn reduce the amount of algae, and then create a plan and evaluate how to fund the best way to control those objectives. So here's the diagrams of your water budget and your phosphorus budget. And I don't need to go through it all, but we'll calculate how much is coming in from these various sources. And then of course, how much is released from the sediment. We do that a few different ways because it's difficult. We don't always measure it directly. We do it both indirectly as well as using literature equations based on sediment phosphorus fraction analysis that we do. And then aquatic plant decay, we can calculate that source as well. And then the losses, of course, well, how much flows out of the lake, how much sinks to the bottom, how much groundwater flows out of the lake, and then if there's any withdrawals for watering lawns and such, not much. Here's an example of one for actually two budgets I did a couple years ago now for Anderson Lake in Jefferson County. Very, very toxic algae bloom problem lake in a state park, actually, that's and then Lone Lake on Whidbey Island. Whidbey Island, that Lone Lake's it's about a 15-foot deep lake. It's very similar in shape to one of your basins anyway. It would be equivalent. And you can just see as an example what you end up with a lot of these lakes, not necessarily yours or any others as well, but in these two, both cases, we have this high amount of sediment release on an annual basis is about 50 to 60%. But if you break it off into the summer months, which is what's important, that's when the algae are growing, you get over 80%, even over 90% of the phosphorus that is incorporated in the algae we've estimated to come from that recycling process that I referred to. So in other words, and recognizing that it originated in the watershed, but it's coming up in the sediment. So that's why most lake managements include both watershed management to cut off that ultimate supply, but it's going to require some sort of in-lake management to cut off that immediate need until the watershed management's work to reduce the amount of phosphorus that accumulates in the sediment. So let's talk about those external lake management sources. Stormwater management is usually what we're doing, focusing on. We also have wastewater management controls. Sometimes there's septic issues or even leaky sewers. But stormwater management is quite most often needed in urban watersheds, and just erosion prevention is one way to reduce phosphorus concentrations. There's a lot of phosphorus just coming from eroded soils. Street sweeping removes phosphorus from the streets. Detention and sedimentation basins are common. Media filtration, I have bolded here, that's the go-to these days. This example I have in the bottom right is our new state-of-the-art high phosphorus, high flow media filter that we've designed and built, and actually we're monitoring now in Bellingham to reduce the algae problem in Lake Whatcom. And this is took years and years of investigating to come up with the right media that really targets phosphorus. As you know, compost leaches phosphorus, and now we're going back and we're having to replace that with new media that Herrera has designed, and it's very not all media is the same, I guess, is the short story. And there's been a lot of innovation and improvements in those designs. Rain gardens are another example of infiltration. The infiltration galleries are bigger systems, and alum injection. This is aluminum sulfate. We've used it in some occasions. It's done a lot more in the Midwest, not much out west, of injecting aluminum sulfate into stormwater, principally because the college doesn't frown on it, does frown on it around here. And then lastly, public education is always important. I notice on your website, you have what you can do. I mean, controlling erosion of soil, not using any phosphorus in your fertilizer, or not spreading any fertilizer near the lake or in any areas that could run off to the lake. And of course, managing both pet and livestock waste manure is very, very important sources of phosphorus to control. Septic systems are difficult to quantify. I have done quite a few lakes where we've surveyed septic sources using optical Brightner meter that I have, along with using fecal bacteria DNA analysis to identify them. Have been quite successful. Actually, in Black Lake is one recent example. We were able to find some septic systems, and the Thurston County Health Department has gone out to fix those now as a result of that work. Okay, let's get into lake management. I see I only have about a minute left. In lake management, there's a lot. I have 7 that I consider feasible. I have another 7 follow this that are infeasible. I won't talk much about those, but buffered alum treatment is the most common. That upper picture is the one, would be the third treatment we did on Green Lake in Seattle. Buffered is important in Western Washington because our low alkaline or low pH waters are sensitive to aluminum sulfate, which is an acid. So we buffer it with a base, a sodium aluminate, to put in a completely neutral product so that there is no toxicity associated with that aluminum. Phoslock is a relatively new product now. It's been used quite a bit now in Washington. Kitsap Lake has been very successful with it in the last couple of years. And it's a different product, but it uses the same principle, except it uses lanthanum instead of aluminum, that are both 3+ to bind and permanently bind, I say, the phosphorus and stop it in the sediment. It's primarily, it can be used for stripping it out of the water, but primarily for sealing it up in the sediments themselves so that it doesn't cycle back up. Lake circulation can happen in a bunch of different ways, either most traditionally through aeration, that just is air bubblers that break the thermocline and mix the whole lake, or in a solar bee situation, and solar bees can go either to mix the whole lake, or in this diagram below, the alum treatment is one that just mixes the epilimnion. That's usually preferred. And when you mix the whole lake, you can quite often, yes, the blue-green algae then lose their buoyancy advantage, but you tend to get a lot of other algae that may not be toxic, but tend to make the water unaesthetically pleasing, and people aren't really any happier with dense amounts of green algae. What interesting technology in the upper right is hypolimnetic oxygenation. They're doing that in Lake Fenwick in Kent. Fairly successful as far as I understand it, but it just injects oxygen into the hypolimnion. This is a very unique way of getting that oxygen in the water, not only to reduce that cycle of phosphorus up from the sediment by oxygenating the water, but you have to super oxygenate it to get that oxygen to penetrate into the sediment, by the way, or you're still going to be having some release. But it also provides fish habitat. So, you have that squeeze going on with lakes where there's no oxygen in the bottom, high temperature in the water in the top, any cold water fish anyway, and even some warm water fish, when it gets that bad, suffer from not being able to survive the high temperatures in the surface or the low oxygen in the bottom. So hypoaluminate oxidation can help that. Two of the more newer and interesting devices, one being the nanobubbler. That's on the bottom right. Moliere makes a nanobubbler. These are super small bubbles that are thousands of times smaller than a regular air bubble, and they are actually neutrally buoyant. They inject these air bubbles or oxygen bubbles into the water, and they don't float up and create mixing by their movement. They actually sit there and dissolve much more effectively, actually, because of low surface area to volume. And they've worked to basically oxidize the water and keep that phosphorus from recycling up from the sediment. And then the number 5, LG Sonic, is a relatively new company. This is their diagram on the bottom left. They use ultrasound. Well, it's actually, and they use solar powered systems that are anchored in the middle of the lake, and they have a water quality feedback mechanism that turns them on only when they detect cyanobacteria pigments in the water. And they tend to send out ultrasounds not to lyse the algae cells specifically, but more to stop the migration of cyanobacteria up through the water column. And so it supposedly doesn't hurt any of the other animals that live in the water, but it will lyse some cells and primarily prevent the migration of cyanobacteria. It's done quite successfully, reported by the manufacturer anyway, in drinking water reservoirs, but I haven't seen it actually at all in any small residential lakes. And then 6 is various ways of biomanipulation, controlling geese, removing carp, controlling zooplankton either by planting zooplankton, live zooplankton, or removing fish that eat the small fish that eat the zooplankton. So that's like planting tiger muskie to eat the bass that and the perch that eat the zooplankton. None of these really have a real significant effect typically on cyanobacteria blooms, but they may have some effect depending on how they're used. And then lastly, of course, are the algicides. We have 2 legal algicides in our state. PAC 27 is one. It happens to be an actually hydroperoxide type oxidizing. So it actually can be used to control fecal bacteria as well. And it is less expensive than any of the others, but it has to be applied regularly. And you also have the risk of blooms reoccurring in between treatments because all that by killing the algae, you release all the nutrients that are then taken up by algae, and they grow pretty fast and can take hold and bloom before the applicator can get back out again. All right, then here's the list of things that just don't work. Microbes and enzymes have been shown really not to work. Dye is, nobody wants to color their lake dye all summer long, green. Barley straws played around in ponds, in rich ponds, and has been shown to have some effect, but not really practical for an urban lake. Dilution and flushing has been used if you have a clean water for dilution and a lot of water for flushing, but water's pretty expensive these days. They looked at it for Green Lake. It's too expensive to pump drinking water in there. They stopped doing that. And the groundwater has too high a phosphorus concentrations to dilute the lake with groundwater as well. And that's quite often the case, not just in Seattle. Hypoliminic withdrawal on the bottom left has been tried numerous places, including Ballinger, Lake Ballinger in Mount Lake Terrace. They turned that off though, because that water came out so stinky that pumped into Mackler Creek and created brown bacteria scums all the way along Mackler Creek, all the way to Lake Washington. So they stopped using that because of the impact of the discharge. And then dredging on the bottom right, everybody wants to dredge, but it costs millions and millions of dollars, primarily because of the expense of dewatering, finding land to dewater the sediment. And now with, especially in urban lakes with contamination, the disposal costs can get high too. So, oh gosh, I got more. I got to finish. This is just an example of analysis we did for Lone Lake a couple years ago. We recommended further cost benefit analysis of alum, the nano bubbler, and the LG Sonic for that shallow lake. What I said was a 15-foot unstratified lake on Whidbey Island. And those are some comparative costs and key factors of them. And that I will open up now for questions.
Does anybody have any questions for Rob? Yes, Pat. It says goose control. How do they control geese? So our question is about goose control. How do you control geese?
Yeah, that's a good question. I know you've mentioned on your website, individuals can put up goose fencing. There's various products out there, but one of the newer products, what's the name of it? Terry McNabb was telling me about is this laser rock. Yeah, that's what it's called. It's called a laser rock. Look it up, Google it, and they're used quite commonly now on golf courses. But as far as I know, they're legal to use on lakes, and they're these. They come in two forms, one that you can actually mount as a buoy or one that you can mount on your dock. And it sends a green laser around at night only, and it deters the goose from roosting in that area, usually either a beach or a dock. And yeah, and just using it at night to deter the geese. So it's fairly cost effective, and Terry swears by it. So give it a try. Yeah.
Okay, anybody else have questions? Brian?
I guess-
Yeah, you had the mic.
Yeah.
Yeah.
A question I have is about where they make the measurements of the cyanobacteria, and then they basically declare the entire lake has been contaminated. Is that really the right way to do that, or should the measurements be made around the lake? Is it not just the surface? Is it in the water? I mean, what's the right way to really understand whether there's a real threat?
Well, I share your concern. I've raised that concern many times. The system is not perfect by any means. So two things. For one, we're sampling the densest scum that we can find on the lake, and then we close the whole lake. Doesn't make a lot of sense to me either. But I don't write the rules. And so the Department of Health, the State Department of Health, sort of worked it out with the local health jurisdictions. And now some of the different local health jurisdictions are actually doing it slightly differently. I'm dealing with Clark County, which does it way differently than King County. And they're closing their lake all the time because they have a super low criteria. They take 1 out of 5 samples from their beach. And if anyone exceeds the criteria, they shut down the beach until all 5 come up clean every time. And so it makes it very difficult. The short answer is, one of the best advice is, if there's a scum, you shouldn't be having water contact with scum. I've looked at data after data after data, and when you sample outside of a scum, even if there's scum on the lake, you're not going to find toxic concentrations, meaning those that exceed the guidelines. It's only in the scum itself that you find these really high concentrations. And in fact, there's methodology for sampling scum. Some people are actually sucking up the scum and they're not supposed to. Well, I should say they're not supposed to. According to King County, they sample below the scum, not the scum itself. And so it's just a problem. We don't have, in my opinion, a good scientific way of truly assessing the health risks based on the toxic algae samples that we're collecting.
Okay, that was an excellent question, Brian. I've been talking to our environmental health department about this and talking to the state and trying to find a better solution, but it's going to take some time. Okay, does anybody else have questions for Rob? Ramon, you want to stand up here now in the mic, please?
Yes.
Thank you.
So I wanted to ask, I wanted to test the accuracy of something that my HOA told me. So I live in the northern lobe of the lake where the water from Hicks Lake comes into Lake Pattison. And I was told that after Marvin Road was redone, and the culvert that brings in the water was improved, that had a direct effect on the water quality in the north lobe of the lake being very good. And the reason why it's not so good in the southern part of the lake, south of the trestle, is because the outlet there is clogged, the outlet that goes to Long Lake. Is that true? And would unclogging that outlet help water quality on the south lobe of the lake?
Well, I don't know enough about it to answer that question, but I would say my first thought, from what you're saying, if the outlet is truly clogged, where's the water that's supposedly coming in and not going out going? Is the lake flooding? I don't think so. I have a feeling that the water is getting out.
Maybe clog is not the wrong word. The water is not flowing as freely. That's what I was told. Because, and when I've paddled by there, you have lilies and other things like that. I mean, I'm sure there's flow under the surface of it all, but that's what I'm just testing something that my HOA told me, and I just want, since you're the expert and they're not, obviously.
The water's been about 10 inches high
10 inches
over
higher.
the last year.
Okay.
Yeah, I mean, you can do the math. What's the flow rate in? What's the flow rate out? What's the change of volume in? And you can, or I should say, you can say, see what the change of volume is. You say it raises 10 inches over the surface area. What volume is that versus the flow rate? And you can determine, because what can happen is you can block an outlet and restrict the flow, but it finds its way through it anyway. The higher pressure, it raises the level, it gets a little bit higher pressure, it pushes through blockages, it ends up pushing through shallow groundwater, cracks in the soils, that kind of thing. Water finds its way out typically if it's under pressure, more water coming in, yeah. But the concept is valid. If you can, sounds like what's happening is the north lobe was cleaner because cleaner water was flushing either the high nutrients or the high algae out of that lobe, and that sounds like a valid point. Another thing is you can get colder water. Temperature really affects algae growth. If you cool it down with cleaner or with cooler water, that can reduce the amount of algae growth. And so all that stuff is potentially could occur.
Thank you.
Okay, I know it was a lot of information. We didn't give them much time and it was complicated, but I know some of you have studied this a little bit so you could follow it. Does anybody else have any other questions? Any other questions for Rob? Yes. Come on up, Tom. I need to speak into the microphone.
Directly into the microphone.
Yes.
We know that there's a turf farm right near us that pumps thousands of gallons of water out of Patterson Lake into that area. Is that are people at risk because that's airborne? It goes into these big irrigation systems, and is the toxins toxic to that environment too?
That's a good question. It's not very well known. I do know there is some incidences of airborne cyanotoxins from aerosol of irrigation waters. There's a case that Don is looking at in Twin Lakes near Federal Way, where they're doing the same sort of thing at the golf course, and they're using Lake Jean water. It's possible, but yes, if there's toxins in the water, I mean, that's the way we get sick from toxins, is by ingesting. We will irritate your skin, but it's not going to give you liver cancer or liver or nervous failure. You're not going to get sick unless you ingest the water or breathe water droplets. But if you think about it, breathing water droplets is typically a really small amount of water, so it's not likely to have much toxin in the aerosol than it would be compared to if you swallowed water swimming. And they calculate that guideline based on assuming that a child swallows, I think it's 100 milliliters of water or something, I can't remember, but it's some, standard calculation, but if you think about it, you'd have to breathe a lot of water droplets to probably get to that quantity of water that you potentially could swallow swimming. So to me, it's not a very likely to be a very high risk, but then again, I would not be walking around while they're spraying water in the air either to be safe. Yeah. And once it gets on the ground, it's a moot point. It's in the ground. It decays. It's remember, the only way toxic cyanotoxins can affect you is if you ingest them into your system.
Hey, any other questions for Rob? Okay, well, thank you, Rob. We very much.
Okay, it was nice spending time with you all, and Paul, keep in touch. If you have any more questions, I can help you out.
Great, thanks so much. Have a good
Okay,
evening.
bye-bye.
Bye.
Yep, thank you. Bye.
Have another question, I don't know if you can, is this the kind of thing that our IVAN, our like study would be assessing?
Yeah,
And that's,
so he would, so he,
talk about the first thing that Ellen.
okay, so the first thing, our county process, to do an integrated vegetation management plan. And anytime you do anything scientific, you study what's there first. So if you start treating something and you don't know what's there, it's not effective and it's a waste of money. So they go around and they study the whole lake, they check what kind of plants are there. All the things he talked about, the Secchi disc, which is a round black and white disc, they drop it down to see how far they can see down, they check water temperature, dissolved oxygen, all these different water quality tests, and then map the whole lake. So then they have all the data to start with, and then they look at data probably like he did here, which was very nice of him. He did this for free. He just went online and got all of the data that he showed here and put them in charts. And then, so they'll put all that together in a plan. If you want to see a sample plan, you can go to Department of Ecology website and look at their sample integrated plans. And then they'll recommend treatment. So they'll recommend all different kinds of treatments that they could do. Then that report will be shared with the group. So whoever wants to come to the meetings, I think they do 2 meetings with the public. And then they work with the county scientist and talk to the county scientist about what would be realistic within our budget and within what we want to do, accomplish the first year. There are priorities, and then there's also the timing. You can't do everything at once, and you usually have to do it in the spring. All the treatments are usually done in the spring. So it's a complicated system. It's an ecosystem. You just don't, you try one thing, it might not work, and you try something else and it does work, and you just don't know. It's and not all lakes are the same, so you can't say whatever works on one lake is going to work on our lake. So yes, some of those things that he talked about would be things that would be in the integrated aquatic vegetation management plan. So does that help? Yeah, and Rob is a great guy, and all those people that I've met in water quality have been wonderful to work with through the years. They're very personable and used to working with like groups. Mike.
Is there interaction with fish and wildlife that you got at?
Yes, I believe they work with all the agencies, DNR, Fish and Wildlife, and there's another one, Ecology. I believe there's some interaction with them. Yeah. Yeah, we'll learn more as we go through the process, but the county handles all of it. They send out the request for proposals, they pick the company that's going to do it, they handle that, they supervise them, handle everything. Brian.
Has the county found a replacement?
Not yet. They've done 4 interviews. They're down to doing the top 2 people for a second interview. They're hoping to have somebody by end of November, early December on board. Yeah. Yes. This sounds like something that would take several years to accomplish.
For a period of time.
Yeah, the Lake Management District is a time period of 10 years. Yeah, so the first year is that study. And then the second year, you would start any kind of treatments that you would do. Yeah, it is a ways away. And tomorrow at the Board of County Commissioner agenda setting session in the morning at 9 o'clock in the morning, they're probably going to talk about it a little bit. So if you want to turn on that, go to Thurston County law.gov to the website and go to the agenda setting session. Click on that, you watch it live, and then there are meetings at 2 o'clock. I don't think they're going to discuss it at 2, but I think they're going to discuss some of it at 9 in the morning. But no guarantees, they don't tell you for sure, you just have to spend 3 hours watching it and see if they talk about you. Ramon, doesn't match your name correct.
Yes.
Okay.
The creeks that connect the lakes, under whose jurisdiction do they come up?
Probably DNR, DNR owns the water bodies. Department of Natural Resources. Yeah. So let's see, I also want to give a shout out on those 5 mile/per-hour signs. Margaret brought them to our last couple of meetings, that are those great big signs. She ordered those, they're really good signs. We got tips from Long Lake on what kind of signs to order. And so John Garrett put those up this summer underneath the railroad tracks. And then the buoy, one buoy is good, the other one needs to be fixed, and we have a guy who's gonna work on that. And just update it, we have new stickers for the buoy, so he said he was gonna do it this month, but I haven't checked him, so. And finally, again, I'm gonna ask for donations. If you haven't donated yet, please put it in the blue bucket with Mike in the back. Or mail a check to us and mail it to Celia, so you can talk to her about her address. So that's all I have for this evening. Thank you very much for coming, and we're done a little early, so you can go have a cup of tea at home.
Okay, hang on.
Anytime I could bring my camera, microphone and point it.
I think
That'd be,
Yeah,
do this.